Okay, for our second sample problem, we are given a plate with a width of 300 mm and a thickness of 20 mm is to be connected by two plates of the same width with half the thickness and has a 25 mm diameter rivets. The rivet holes have a diameter that is 2 mm larger than the rivet diameter. The plate has a yield strength of 248 megapascal noted by the symbol Fy. It also has an allowable tensile stress on the net area that is equal to 0.60 Fy or 60% of our yield strength. And lastly is the allowable bearing stress of 1.35 Fy, 1.35 times Fy. Then the rivets have an allowable shear stress of 150 megapascal. So unlike sa atong first example, ang kini siya is double shear na siya. So ang giingon dire is same ang thickness sa plate, then same ang width rather and half ang thickness. So this is 300 mm ijang width and ijang thickness is, if this is T, then this is T over 2. Then if this is P, then this is P over 2 kay aron equilibrium gyapon. So determine the following. First is the maximum load that can be applied to the connection without exceeding the allowable tensile stress in the plate. Then again sa B, maximum load gyapon that can be applied to the connection, this time without exceeding the allowable shear stress. And sa C, maximum allowable load gyapon nga pwede i-apply sa connection, this time without exceeding the allowable bearing stress between the plate and the rivets. So ganiha, ang atong gipangpangita is ang mga shear man, shear, tension og bearing. Karon ang gipangita is ang loading or ang P nato without exceeding sa ilang mga allowable nga stress. So for our first problem or first unknown, which is the tensile stress in the plate. So before ta mo proceed, ato sang i-identify ang tension sa net area, which is equal to Ft. So ang atong tension stress is 0.6 Fy. Then given man ang atong Fy, which is equal to 248. So 60% of 248, that is equal to 148.8 megapascal. Then net area sa plate, so atong i-recall ang area na to sa atong saka plate. Dire nga may experience og tension. So kini siya nga area, it is ijang base, and then ijang length, then ijang width. So na may duha ka area kini og kini nga wa ning undergo og tension, so ato nang i-minus. So 300 kini dire is subtracted by kani nga area. So ang kani nga area is 25 plus 2 kay ang diameter ani niya is 2 mm larger than the diameter sa rivets. Atong i-recall sa problem. So 25 plus 2, since duha man ka buok, so times 2. So kini siya nga equation mo ni ang base, then multiplied by the height, which is 20. So ang atong area or net area sa plate under tension is 4,920 mm squared. So nanatay tension sa net area o ang net area sa plate. So pwede na ta mo proceed sa atong load, which is equal to P is equal to the tension and the area. So 148.8 multiplied by 4,920. So ang atong makuha nga loading nga P is 732,096 Newton. Or og atong i-convert into kilonewton, that is 732.09. So next is ang shear sa rivets. So since involved naman ang rivets dire, so mao ni upat ka buok. 1, 2, 3, 4. So atong i-recall sa atong drawing, which is ang katong upat ka buok is mao ni 1, 2, 3, 4. So nag-connect tong upat ka rivets sa kuan plate, duha ka plate. So ang formula ni Ja is kini shear is equal to P over A, derived from the formula nga P is equal to shear times A. So ang atong P karon is equal to is equal to the shear stress times the area of the rivet. So ato sang kwaon ang atong shear stress, or rather given man si Ja. So atong shear is equal to 150 megapascal, which is given sa atong problem. So karon ang atong kwaon nga area is ang total sheared area. So note nga ang atong given karon nga plate is double shear, since duha naman ka plate ang present. So area is double shear man, so 2 times the area sa atong rivet. Then since upat man ni kabuok, so atong multiply by 4. So we have pi 25 squared over 4 times 4, then times 2. We get the area is equal to 3,927 square millimeter. So ano naman tayo area na napuntay shear, so makuha na nato ang atong load nga P. So P is equal to shear times area, which is 150 times 3,927. So ang atong loading nga P is 589,050 Newton. Or katong i-convert og kilonewton, that is equal to 589.05 kilonewton. Then last atong anon is the maximum load nga pwede i-apply without exceeding sa allowable nga bearing stress. So bearing stress between the plate and the rivets. So ang area nga mukuan sa bearing stress is kini si Ja dire nga kuan since do. So atong FP, or ang kanang FP is equal to 1.35 Fy, o kuani ang atoning kanang limit sa bearing stress. So we have 1.35 times ang atong Fy, which is ang yield strength nga equal to 248. So ang answer na is equal to 334.8 megapascal. Then the area, or the bearing area of the 4 rivets is 25 by 20. So 25 man ni dire as sa given nga 25 in diameter. Then ang height ni Ja is 20 man. So we have 25 times 20 times 4 kay upat ka rivet. So we get 2,000 mm squared. So since na naman tayo area na napuntay bearing stress, so ato na makuha ang loading nga P. So atong P is equal to the bearing stress, which is equal to 334.8 times 2,000, which is the area. So ang atong answer ana is 669,600 Newton, or atong convert into kilonewton, we have 669.6 kilonewton. So mao to si Ja ang atong solution, or these are the 3 solutions to our 3 unknowns for our second problem, sample problem. And then ang katulong third sample problem is ano pong i-explain on the next video.